Hello everyone, and welcome back with Mrs. Struble. Today in this video, we're going to be practicing how we add rational numbers. Now remember that a rational number is any number, whether it's positive or negative, that can be written as a fraction. This includes integers, decimals, mixed numbers, fractions, or most decimals, I should say. Not all decimals. Okay, most decimals are rational numbers. Some are not. We'll get into that in a later video. But it also obviously includes mixed numbers and fractions. Okay. So how do we add rational numbers? Well, here's the great news. If you know how to add integers already, which by this video, hopefully you do, then the rules of adding rational numbers are not really that different at all. Okay. When we are adding rational numbers, two different things can happen. We can have the same sign, where we have both positive numbers or both negative numbers, or we could have different signs, where one value is positive and one value is negative. Okay. When we have values that have the same sign, so we're looking at two negative numbers being added together, whether they're decimals or fractions or mixed numbers, it doesn't matter, but they're two negative numbers. Okay. We are going to first add their absolute values. So we're going to find the absolute values of these numbers, and then we're going to add those together, the absolute values, what we get. Okay. Our second step is to keep the sign the same. Okay. So if we started with negative numbers, our answer is going to be a negative number. If I'm in debt, I owe somebody money, and then I borrow more money, I still owe money, but I owe that much more. So the answer will always be a negative if I have two negative numbers being added together. Well, the same thing goes when we have two positives, as we have learned definitely by now. Okay. If I add two positives together, I just take those numbers, I add those numbers because they're already in a positive absolute value form, and the answer would be a positive because we started with positive numbers. Okay. From there, it's all about, do you remember how to add the specific type of rational number we're working with, whether it be a decimal, mixed number, fraction, or integer? Do you remember how to add a decimal, a normal decimal? Do you remember how to add a normal fraction or mixed number? Okay, and we'll get into some examples to help jog your memory. The other thing that could happen with rational numbers is they could be different signs. So we could have one negative value and we're adding a positive value to it. Or we could have one positive value and we're adding a negative value to it. Okay. In this case, we still have only two steps. Step one, we're going to take the absolute values, but this time we're going to subtract those absolute values. Okay. So we're going to take the absolute values of both of these numbers and we're going to subtract them. Now, when we find the absolute value, we need to identify which absolute value is greater so that we can do our subtraction properly. So if this one is greater, for example, then it would be the first number on the top of our subtraction problem. Okay. Now our answer, the sign of our answer, so is our answer going to be a positive or a negative? What determines the sign of the answer is which value was greater. So in this case, the absolute value of the positive number is greater. So that means I have more positives than I have negatives. So our answer is going to be positive. If the negative was the greater absolute value, then our answer will be negative. Okay? So the greater absolute value essentially wins the sign, okay? So wins the sign of the answer. Right? So you're looking for which absolute value number is greater, and that's going to tell me if the answer is a negative or a positive. Let's try these in action. We're going to start off with decimals here. Okay? And then we'll work our way up to fractions, and then we'll do one with mixed numbers. All right. For example, let's do negative 0.75 plus negative 1.5. Okay? Always going to ask myself that first question. Same sign or different signs? I need to know which one to follow, which rules to follow. Here we have two negatives, so they are the same sign. They're both negative. So I'm going to follow this rule, these rules. Okay. Now, what does it tell me? First, we're going to add the absolute values. Well, let's find those absolute values, shall we? So I'm going to put those absolute value notations. The absolute value of negative 0.75, well, how far away is 0.75 hundredths from 0 on the number line? It's just 75 hundredths. Remember, it's just the positive form of that value. Same thing with negative 1 and 5 tenths, or 1.5. The absolute value is 1 and 5 tenths. Adding those absolute values like it tells us to do in step 1, we have to remember, how do we add decimals? Now remember, when we add decimals, we got to line up those decimals, okay? So we have 75 hundredths, 0.75. I could go ahead and put the 0 in front if I want to, but that second number, the decimal, needs to go straight below the first decimal. So I put the decimal in right away, okay? Now take a look at that second number. It has a 1 in front of the decimal and a 5 after it. So I just make it match. Now I have a spot that's open, or it has nothing. We can always add a 0, and that does not change the problem. Okay? At the end, we can always add a 0 at the end. That doesn't change our problem. So now we just add, and the decimal falls straight down. 5 plus 0 is 5. 7 plus 5 is 12. Carry the 1, and then we have 2. So our answer is 2 and 25 hundredths. We added the absolute values. Now, second step says to keep the sign the same. What sign did we start with? What were they? Were they positives or negatives to start with? In this case, they were negatives. So our answer is going to remain a negative. Negative 2 and 25 hundredths is our final answer. Let's go ahead and try another one. Let's try this example. We're going to stick with decimals here. And we're going to say, what if we have a problem, like this? Let's do negative 5 and 35 hundredths plus 4. Okay. Now again, we first have to ask ourselves, which rules are we going to follow? Are they the same sign or different signs? Okay. So same or different, We take a look, we have one negative, one positive. We know these are different signs. Different signs, our first step is to subtract the absolute values. So different signs, we take the difference, which means we're going to subtract. So they're different signs, so we're going to end up subtracting. And then whichever number has the greater absolute value wins the sign. Okay, so the answer has the same symbol, in positive or negative, as the one with the greatest absolute value. All right, let's walk through this. First of all, different signs. So we're going to take the difference or subtract those absolute values. Let's find them. There's our two numbers. Here, let's use green. It kind of stands out a little more. -5 and 35 hundredths. The absolute value of -5 and 35 hundredths is 5 and 35 hundredths. The absolute value of 4, well, that's just 4. We're going to subtract these two numbers. Let's go ahead and set it up as we would a decimal problem. Okay. We know we're going to subtract these two numbers. Which one has the greater absolute value? Let's go ahead and take care of that. Greater absolute value. Well, that was this guy. When I'm subtracting, I need to know which one has the greater absolute value because he's going to go on top. Okay? He's going to be our first number in this subtraction problem. Now, where would the 4 go? The absolute value of 4 is 4, but how would I set that up? We need to remember that all whole numbers, 1, 2, 3, 4, 14, -12, even integers, all integers, their decimal is after them. Okay? So I have the decimal here. I need to pull that decimal straight down, and that's where my decimal needs to be for my second number. The 4 is in front of that decimal. So that's where we're going to put it. And then any spaces, we can add zeros. Right? Now we just subtract like we would normally in a normal, decimal problem. 5 minus 0, 3 minus 0, 5 minus 4. Okay? Now which one had that greater absolute value? That -5 and 3/5. So our answer is negative. The greater absolute value wins the sign. Our final answer, -1 and 35 hundredths. Okay, let's move into fractions. We're going to use the same rule. Super nice, right? So basically we're asking ourselves 3 things. First, we're going to ask ourselves, are they the same sign or different signs? Then, okay, if they're the same sign, are we going to add or subtract? Remember, different signs we subtract, same signs we add. And again, we're talking about those absolute values. So add or subtract those absolute values is the second question. The final question we have to ask ourselves in any of these problems is, what's the sign of the answer? When we have the same sign, the sign will stay whatever it was to begin with. When we have different signs, one's positive, one's negative, then we have to figure out which one has that greatest absolute value, because that's the one we have more of, and that's the sign of our answer. Okay, here we go. Fractions. -8/3 plus 5/6. Okay. Same or different? These are different, so we're going to subtract. Okay. We're going to subtract the absolute values. Let's find them. The absolute value of 8/3, negative 8/3 is 8/3, and the absolute value of 5/6 is 5/6. I know I'm going to subtract these two. Are they in the right order? Is the bigger one first? The greater absolute value, is that first? And then, actually it is. So this one is the greater absolute value. I'm going to circle it so I don't forget, because it's more than 1 and this is less than 1. So you could look at it that way. Now, when we're dealing with adding and subtracting fractions, we need to have the common denominator. Here, we can see that the common denominator would be 6. So we're going to take this first fraction and we're going to change it so that we have a 6 in the bottom. We do that by multiplying it by a unit of 1. In this case, 2/2. So 2 divided by 2 is 1. We're not changing the fraction, what it means. We're just changing how it looks. Okay? So this becomes 16, 8 times 2, over 6, minus 5/6. Now that we had the common denominator, we can subtract straight across, subtract our numerators, and then the denominator stays the same. The denominator is basically just telling us how big these pieces look, okay? Not how many they are. So that stays. So 16 minus 5 is 11. We have 11/6. If we would like to, we could change that. And we realize that that is 1 with 5 extra pieces left over. Now we have to figure out, well, what's the sign of my answer? We subtracted, which means we need to keep the sign of the one that we have the most of. So we had more negatives than we had positives. The answer is going to stay negative for that reason. And there you go. Okay. All right. Let's see if we can do a whole mixed number problem. And then I'm going to give you some problems to try on your own. All right. Oops. We're going to do it this way. Negative 1 3/8 plus negative 3/4. Okay? Again, our first question, same or different? Which rules am I going to follow? In this case, we have both negatives, so they are the same. That means we are going to add the absolute values. Let's find them. The absolute value of negative 1 3/8 is 1 3/8, and the absolute value of negative 3/4 is 3/4. Okay. Adding these up, the way we set up mixed numbers is vertically, okay? So let's take 1 3/8 up top and then 3/4 right here underneath. And we know we're going to add, okay? So they're different, they're the same sign, so we're going to add. Our answer is going to be a what? And we could go ahead and put that in right now. We had 2 negatives, so we're not digging ourselves out of the hole. We're actually digging deeper, right? So our answer is going to stay negative. The sign stays the same, negative. Now we can do our math problem using our rules of how to add mixed numbers. Find that common denominator. We're going to change this guy so that the denominator is 8. We have 3/8 plus 6/8. That's 9/8. And then 1 plus 0 is 1. Now we can deal with this guy. This is what we call an improper. So we realize that there is more than 1 here. Our answer is still going to be negative, so that continues. But 9/8 is more than 1. with 1 left over. Okay, so this is actually 1 with 1 left over. 1 plus 1 gives us 2 total with 1/8 left. There you go. All right, here we go. And I know this video is getting a little long, so let's finish this up. I'm going to give you a couple problems, both fraction and decimals. Have you try them out. Pause the video to try them, and then I'll be back with the answer to see how you did. Okay, there's your 4 problems. Try them, pause the video, and I'll be back with the answers, okay? Now that you've given them a try, let's get started on the answers. Number 1 was -2. Number 2 is -6. And something happened with 3 and 4. Turns out that they're both equal to 75 hundredths. So that was kind of cool. Okay. If you missed one of these, make sure you try them again. See if you can find your mistakes. If you are not understanding where you went wrong, come see me. Okay. We have now successfully completed our video over adding any rational numbers. We already discussed integers, so we were focusing on decimals and mixed numbers with fractions. Okay. Right. Thank you for joining me. After the conclusion of this video, you can go ahead and get started on your adding rational numbers assignment, and I will see you again next time.